Welcome to Spark STEM Scholars.
Hi everyone, today we'll be going over quadratics on the SAT math. So what are quadratics? A quadratic is a function in the form of ax squared plus bx plus c, with the highest power being 2. The graph of a quadratic would be a parabola, which is sort of a U shape, like so. Let's walk through a few examples. Example 1, f of x equals to x squared minus 4x minus 21. So first, let's find the roots. What are roots? Roots, which can also be referred to x-intercept, 0, or solutions. It is values of x that makes f of x equals to 0. To find the root of our quadratic here, we can use factoring. Once you factor f of x, you would get x minus 7 times x plus 3, set that equal to 0, and you would get x minus 7 equals to 0, x plus 3 equals to 0, and therefore your x values are 7 and negative 3. Graphically, this means that this quadratic crosses the x-axis on value x equals to 7 and x equals to negative 3. So x equals to negative 3 here and 7 here. Let's find sum and product of the roots. Now the sum and the product, the sum would be 7 plus negative 3, which is 4, and product would be 7 times negative 3, which is negative 21. But sometimes we will have to find the sum and the product of the roots without knowing the roots themselves. How can we do that? So if you don't know the roots of a quadratic, so given the formula of y equals to ax squared plus bx plus c, the sum would be equal to the negative b over a, and the product would be c over a. Here in our first example, our a will equals to 1, b equals to negative 4, and c equals to negative 21. So the sum, if you're using this formula, it will look like negative 4 over 1, which is 4, and our product is negative 21 over 1, which is negative 21. As you can see, the answers are the same. Now let's go over the vertex. The vertex is the midpoint of the root. This is the vertex. And since the x-coordinate of the vertex is always the midpoint of the two roots, then we can find the x-coordinate by averaging the two roots, which would be 7 plus negative 3 over 2, and you would get 4 over 2, which is 2. And once you find the x value, you can plug it back into the equation, which is f of 2 equals to 2 squared minus 4 times 2 minus 21, and we would get negative 25. That means the coordinate of our vertex is at 2, negative 25. The vertex can also be our minimum. and it would be the maximum if our graph is the upside down U, which would be here. That's also the vertex. So the vertex of this graph is 2, -25. Now let's talk about the vertex form. So our standard form is y equals to ax squared plus bx plus bx plus c. And our factored form is y equal to x minus a times x minus b. And in our vertex form is y equal to a times x minus h squared plus k. And here we can get our vertex because hk would be our vertex. So the vertex form will give you our vertex coordinates. So how do we get our vertex form? So to get our vertex form, let's use our first example of x squared minus 4x minus 21. And we'll do something called completing the squares. So to complete the squares, let's look at our b value. Our b value is -4. First, we'll divide the b value with 2, and we'll get -2. And we'll square the -2 to get 4. And we can rewrite this part of the quadratic into x squared minus 4x plus 4, because this part will give us a perfect square. Now, to subtract 21 by bringing this down, this equation, our second equation, will not equal to the first equation right now because there's an extra 4 here. So to cancel out the 4, we need to subtract 4 so that these two equations would be the same equation. Now, rewrite this part into our square, so it'll be x minus 2 squared, and -21 minus 4 is -25. And as you can see, our h equals 2, our k equals to -25, and our coordinate would be 2, -25. See how simple is that? Just do a bit more practice and you will get more comfortable with completing the square. So as you guys may know, there's another way to find our solutions or our values of x by using the quadratic formula. The quadratic formula is -b plus or minus square root of b squared minus 4ac. Divide everything by 2a. This is an important formula to know and memorize on the SAT because once you can't factor, then you will need to use the quadratic formula. But right now, let's shift our attention to the formula in our square root. Now, b squared minus 4ac, this part is particularly known as the discriminant. So let's calculate our discriminant for our first example of x squared minus 4x minus 21. Our b is -4 squared minus 4 times 1 times -21, and we would get 100. Now, what's so important about discriminant? Well, the value of discriminant does not matter. What matters is the sign, whether it is positive, 0, or negative. So when the discriminant is positive, or when d is greater than 0, then the graph will look like this. This means that there is two real roots. But when there is 0, when d equals to 0, then the graph would be something like this. Then the graph would be something like this. This means that there is only one real root, where the graph only touches the x-axis at one point. When d is negative, which is less than 0, then the graph would be like this, when there is no real root. So in short, the discriminant tells you how many solutions are there, how many real solutions are out there. So as you can see, our example have two real solutions since 100 is greater than 0 and is positive. Let's move on to our second quadratic. F of x equals to negative x squared plus 6x minus 10. Now let's first get our discriminant. So our formula for discriminant is b squared minus 4ac, and we will get 6 squared minus 4 times negative 1 times negative 10, and we will get negative 4. Since our discriminant is negative, that means that there is no real root. So our graph will look something like this. Now this is an upside down U because our x squared is negative. Let's find the sum and product of the roots. Remember our formula for sum, negative b over a, and our product is c over a. So our sum, negative b over a, that'll be negative 6 over negative 1, which equals to 6. And our product is negative 10 over negative 1 equals to 10. So now you may pause here and think, how are there sum and products of the roots when there's no real roots? Well, the quadratic doesn't have any real roots, emphasis on the real, because it does have imaginary roots. So the value here are the sum and product of the imaginary roots. We will cover imaginary numbers in later lessons. But here, let's find our vertex. Because we don't have our real roots to find the average of, we need to convert this quadratic into its vertex form. So the vertex form, since our x squared is negative, let's multiply both sides so that our x squared is positive, which is easier to work with. So we'll have negative y equals to x squared minus 6x plus 10. Now divide our b value, which is negative 6 over 2, and we will get negative 3. And the square of that is 9. So our negative y is equal to x minus 3 squared. Now we need to remember that we need to minus or subtract 9 from our constant. So that will be plus 1. Now we need to multiply both sides by negative 1 again so that we can make our y value positive. So y is equal to negative x minus 3 squared minus 1. So as you can see here, our vertex is at 3, negative 1. So this is our vertex, 3, negative 1. So let's take a look at this problem. How many times does the graph of x equals to negative x squared plus 6x plus 3 intersect the line y equals to 10? First, we substitute. We plug in the y value. Our y value, 10, will be 10 and equal to negative x squared plus 6x plus 3. And move everything to one side, we'll have 0 equals to negative x squared plus 6x minus 7. Now, since they're just asking for the amount of times the graph intersect each other, we do not have to find the value of these intersections. So what you can do is to use the discriminant. So to find our discriminant, it would be 6 squared minus 4 times negative 1 times negative 7, in which you will get 8. And since our discriminant is positive, that means that there is 2 real solutions, which also means that there are 2 intersection points. Let's look at this one. Y minus k equals to 0, y equals to x squared minus 3x plus 1. K is constant. What value below can k be if this system equation have no real solutions? Now, if you think back to it, when there is no real solutions, our discriminant would be less than 0. So let's find the discriminant of this system equation. First, let's find the value of y. Value of y is k. So replace y with k, and we will get k equals to x squared minus 3x plus 1. Move everything to one side. X squared minus 3x plus 1 minus k. And now, since k is a constant, it is with the 1. So a is equal to 1, b is equal to negative 3, and our c, it is 1 minus k. So now plug these numbers into our formula for discriminant, b squared minus 4ac, and we will get negative 3 squared minus 4 times 1 times 1 minus k. We would get 9 minus 4 plus 4k, which is 5 plus 4k. Now, we can just plug in our answer choices and see which one will give us a negative discriminant. So let's try negative 2 first. 5 plus 4 times negative 2, that's negative 8, so it will be negative 3. We got our negative answer already. But so that means that our answer has to be A. But just for the fun of it, let's try other choices too. So 5 plus 4 times negative 1, that's just 1. 5 plus 4 times 0, that is just 5. 5 plus 4 times 1, that is 9. So our obvious answer is answer choice A. Try the following 2 problems on your own. Pause the video and see if you can get the right answer. Find the sum and product of the roots of 2x minus 3 squared equals to 4x plus 5. First, let's multiply them out. So 2x minus 3 times 2x minus 3 equals to 4x plus 5. We would get 4x squared minus 6x plus 9 equals to 4x plus 5. Now have everything on one side. So we would have 4x squared. This is 12x here. Now subtract 4x on both sides. We have negative 16x. Subtract 5 on both sides, and we have plus 4 equals to 0. Now to find the sum of the roots, we use negative b over a, which is negative 16 over 4, which would be 4. And our product would be c over a, which is 4 over 4, and it is 1. So our sum is 4 and our product is 1. Did you guys get that? If you guys did, great job. Now for the second problem, for what value of t does the equation v equals to 5t minus t squared result in the max value of v? Now, we do know that when we look for a maximum or minimum, we're looking for the vertex. So let's factor this equation. V equals to t times 5 minus t. And if we set it equal to 0, t will equal to 0 and t will equal to 5. So these are our two roots, and to find the vertex, we need to find the average of the roots, which is 5 plus 0 over 2, which is 5 over 2.
Great work today. Keep practicing and you'll be ready in no time. If you find this video helpful, please like and subscribe and share with a friend. See you next time.